Okay, let's talk about covalent compounds. So before we talked about ionic. Ionic was between metals and nonmetals, and the metals donate or lose their electrons to the nonmetals. So the cations, the positive ions, are for the metals. That's on the left-hand side of the periodic table. That's where the metals are. The anions form with the nonmetals. That's on the right-hand side of the periodic table. And electrons are transferred between the certain number of atoms to fill the octet. So that's all review. Octet means 8. So 8 electrons have to fill the outer shell, so the valence shell of each of the atoms so that they can be stable. But now what if we consider chlorine gas, Cl2? 2 chlorine atoms are bonded together. Why is that unlikely to be ionic? So, if we look at where chlorine is on the periodic table, it's on the right-hand side. So they're both nonmetals. So they both want to gain electrons, and this makes sense because then it would have a full octet like argon. So you can't make ionic if they both gain electrons. You can only make ionic if you have a metal, left-hand side, and a nonmetal. So that would be the answer there. Ionic bond is unlikely to form because both chlorines are nonmetals. Okay, so then what do we do? If we wanted to form a stable compound between 2 atoms of chlorine, what would happen? So remember the Lewis dot structure. This is 1 chlorine. Chlorine is here, so in its valence, if you look at the electron configuration, you've got neon, and then 3s2, 3p, 1, 2, 3, 4, 5. So you have 7 valence electrons, right? Because it's neon, 3s2, 3p, 5. So 7 valence. So how do we show that? 1, 2, 3, 4, 5, 6, 7. So it doesn't have an octet. It has 7 electrons in the valence. So how could 2 chlorines collaborate? Let's put the next one with 7. Well, with a single dot on the left-hand side. And now you can see how, if this chlorine didn't lose, but if it shared its electron with that chlorine, and same thing here, then we can think of these two as our reactants. And over here we get the product, where those 2 shared electrons belong to both chlorines. So that's a shared pair. And it's called covalent. Co as in both. So co like collaborate or cooperative or together. So together, valent. It's in both valences. And that's a covalent pair or a covalent bond. So when we talk about a chemical bond, we could be talking about an ionic bond like we did before. If it's not a shared pair, but you're losing 1 electron from a metal to a nonmetal, or we could have a shared pair, and then that's in both valences, so it's a covalent bond. And that's basically what this talks about down here. And each line here is representing a covalent bond. So we could also draw this like this. Cl with a line between another Cl. And that line is the same thing as a covalent bond. If we share one pair, we draw a single line. Sometimes we can share two pair, and then you would have a double line, or you can even share three pair and have a triple line. So two pair, obviously, that would be 4 electrons here between the carbon and the oxygen. And three pair, this would be 6 electrons for the triple bond between the carbon and the nitrogen. All right, let's take a look at ozone. So question number 3 here. How could that form? And it's a little trickier. I want you to try. So think about oxygen. So oxygen is here. So that's helium and then 2s2, 2p, 1, 2, 3, 4. So you have 6 valence electrons. So we could draw 6 dots, maybe something like this. And then think about, okay, how could you make a molecule that's O3? Each oxygen has 6 dots. How could they come together to make a molecule? All right, go ahead and try that, and in the next video I'll show you the answer.